Welcome, everyone. I'd like to welcome you on behalf of the Net Zero Industries mission to the latest Now Industry Insights webinar series. Our title today is Net Zero Cement, Building a Sustainable Future. We have a range of speakers for you today and tonight, depending on where you are. But if I could first, please, I would like to give a warm welcome to Urban Paker. Urban has recently been appointed as the new mission director for the Net Zero Industries mission, representing our co-lead nation of Austria. Now, Urban is currently the head of industry, companies and the finance department at Austria's Climate and Energy Fund, and he brings to the role an extensive experience in industrial transformation, clean energy and financing. Please, for our welcome address, Urban Paker.
Thanks a lot, Alan. Thanks for the warm welcome. It's my great pleasure to welcome you to today's webinar. It seems to be a global audience, so thank you all for joining us, whether you're turning in from across the globe or just next door. We are really delighted to have you here. This is now the 5th webinar in this series and my first as the new mission director, so I'm excited. We have chosen for today the topic of cement, as it plays a really fundamental role in modern infrastructure and development, and it's literally around us 24/7 in our everyday life, and yet it is also one of the most carbon-intensive sectors. Achieving net zero emissions in cement production is a challenge, that's clear, but it's also an opportunity. And the opportunity that requires collaboration, innovation, and bold action, and this is kind of the motto of our mission too. So this is really precisely where the Net Zero Industry mission comes in. We are a global initiative under Mission Innovation, and we are dedicated to accelerating the transition of energy-intensive industries toward net zero emissions. And certainly we recognize that industries like cement, steel, and chemicals are critical to our economies and of great economic value. And they are responsible for around a quarter of global greenhouse gas emissions, and decarbonizing them is essential for meeting our climate goals. Emissions from the energy-intensive industry are obviously particularly difficult and very expensive to abate, with a range of technologies still needed to be scaled up and still need to become commercially available. And one of our main goals, and it's probably better visible on the next slide. If you could move to the next slide, Thomas. Yeah, you see a summary of our mission goals, but I think what it sums up is that our goal is to build trust in new technologies, and webinars like these are meant to help building trust in this. So our goal, as you can see, is to implement 50 large-scale demos across all energy-intensive industry sectors and along different technology pathways. We support fast-track development of breakthrough low-emission technologies to higher TRLs, and ideally, we help to reduce capex on low-emission innovation technologies by over 15%, and that already in the near future. Today's session will explore the latest developments in net zero cement, highlighting cutting-edge technologies and industry best practices. And as Alan has already pointed out, we have an exciting lineup of experts who will share insights into how we can collectively drive sustainable change in the cement sector. And we encourage you to actively engage into today's discussion. So please ask questions, share your thoughts. Ellen will help you in the moderation. And the road to net zero is one that we certainly must travel together. So conversations like this are key to shaping a more sustainable future. Thank you really very much for being here. And I think it's about time to get started. And by that, I would like to hand over to Alan again, who will guide us through today's webinar in his role as the missions coordinator. Thanks a lot.
Thank you, Urban. Everyone, please, we have an exciting agenda for you today. Starting off, every presentation is timed to be approximately 20 minutes. Of that, we have 15 minutes of presentation, and hopefully we will have 5 minutes of questions available for you to ask. If I could ask you just to put those questions in the chat, clearly identifying obviously the speaker if it's for a different speaker that's happened in the past, but that will help us if we have some time at the end to actually ask some follow-up questions. But as I said, we're hoping to have 5 minutes of questions available after each speaker's presentation. On our agenda today, you'll notice on the screen there, our keynote speaker is Paul Adelecki. He's speaking from the Global Cement and Concrete Association, followed by Florian Kleinbacher from Holcim, who will be speaking about the Carbon to Business project. After that, we have the pleasure of Anne, apologies if I get it wrong, Decarbonising, who's speaking on behalf of the, I've got it spelled here, the EPFL University from Switzerland on the LC3 project. And lastly in our agenda, we have Davide Zampini, who's from CEMEX, and he'll actually be talking about CEMEX's projects as well. Following at the very end, we'll be having an end note and wrap up by Urban. If I could, let's jump straight to our keynote. It is my absolute pleasure to introduce Paul Adelecki. Now, Paul leads the Global Cement and Concrete Association's work on global outreach and engagement. Their purpose is to build the understanding, support and joint action on the industry's mission. He has extensive experience and a reputation in public affairs, having worked for global businesses, industries and governments around the world. If I could, please, everyone, welcome Paul.
Thank you, Alan. I'm just going into slide share mode. Give me a quick thumbs up if you see my screen. So firstly, thank you to the organisation and thanks for the opportunity really to give an overview, arguably the easiest task of many of my colleagues, member companies and key stakeholders are actually presenting some of the more technical detail later on. But I wanted to give a little bit of an overview of the work that our sector is doing in terms of decarbonising cement and concrete. This whole event is called cement, but we as an association often talk about concrete because you cannot have concrete, which is the end product. It's the material that we see on our streets, supporting our buildings, our transport network, etc. You cannot have that without that magical powder, that magical ingredient that is cement. But it is cement that is the main cause of the CO2 emissions, and so by addressing them at the cement level, the manufacturer level, but also within the use of concrete as well, we can really actually get towards our net zero vision and mission. So just today I wanted to talk about indeed the essential role of cement and concrete, why it matters, why this challenge is important for society, but then also crucially what the commitment of the industry is and what our map and pathway looks like to get towards zero emissions. But also just a bit of reflection on where we're at, the challenges, the drivers that will help us build this net zero world. And also just a very quick dive into low carbon procurement, which is one of the big focal points for us in terms of driving forward our work on this role. So if you don't know about the GCCA, we're a member company organisation and members who manufacture cement, some of them also concrete, operate in just about every country across the planet, and it's very much a local product, cement and indeed concrete. You can see all our members there. We have about 50 of them, but we also have a number of association partners. So the national associations, the regional associations, who also work with us hand in glove in terms of driving our messages, working with partners, working with communities to ensure that we can collectively build our vision. And we represent around 80% of global cement production outside of China, but also an increasing number of China members are also joining the GCCA, which is hugely important. China, you will know, produces more than 50% of both cement and concrete in the world. So it's absolutely crucial that that is part of our mission to decarbonize. We work with many different organizations. Please, if you're not on this list and you do work with us, I do apologize. If you're not on this list and you want to work with us, do drop a note. But the GCCA exists really to partner with organizations. We cannot achieve our net zero mission alone. We need policy. We need finance. We need the built environment, the full value chain playing its role to help us. So that is our job, to collaborate and work with a whole heap of different organizations. So the essential role of, when I talk of concrete, I obviously mean cement as well. there is a balance. Why is it a problem? Why could we not just not use cement and concrete? Well, actually, no, we couldn't. We need it for society. We need it for transport, for the hospitals, for the schools that we build, for the houses that we live in, for the offices that we work in. It is a local product. There is nothing with the level of strength, durability, cheapness, versatility to be able to construct. But of course, it comes with a level of impacts. The whole built environment and construction is around 40% of CO2 emissions, and within that, building materials around 11%. And the figure that we use for cement and concrete is something around 7% of CO2 emissions come from cement and concrete. But it's that duty that we think our members have, because we deliver this essential material, that we need to decarbonize it. And we're even massively critical for the SDGs, the 17 United Nations SDGs. The estimate figure is that 92% of them needs built environment support to deliver them. And the analysis that we've done suggests that actually cement, concrete are vital for around half of all the work within each of the SDGs. So, and increasingly, it isn't just the climate mitigation which we're needed for, it's climate adaptation and the increasing need for resilience. That big picture is from the hurricane, which was on Miami Beach in Florida a few years ago. Concrete building that remained standing, the California fires. You've probably all seen that picture at the top right. But increasingly with climate catastrophes, let's face them, we need to adapt. And we're going to need concrete, whether that's in flood defences, whether that's in more durable housing and resilience and resilient communities going forward. So it isn't just us saying that. We work, one of the bodies that we work with is the United Nations. He said this at one of our conferences, that 3/4 of the infrastructure that will exist in 2050 has yet to be built. So if you look at that bottom graph at the bottom, that sort of purple block is where we're at now. We still need to build this 3/4 of it. So there's going to be an exponential increase. And of course, that's to do with the mega trends of population growth, of increasing urbanization. But we have to build smarter. We know that as well. We have to be able to sort of recycle our products. We have to encourage architects to use our products with a more minimalistic approach. We have to be able to recycle, reuse the buildings and then the materials that we need. But there's this call to action to our industry from all the stakeholders. And that is why in 2021, our member companies and the industry under the GCCA came together to make this global commitment, to set out a credible pathway to get to net zero. And I believe we're the first global industry to do that. Now, it's not that work wasn't done to drive down emissions over the previous years. And we've sort of said that initial progress from 1990, which when we started to monitor the CO and transparently report the CO2, we're again one of the first industries to do that of our manufacturing. You can look on our website to see that every year we report those figures to show that there was indeed improvements in reduction of CO2 emissions. But we think that this decade ahead is a crucial decade to deliver, where we have to accelerate those reductions, but also set ourselves up for the end of the decade, where some of the more transformational technologies will come on tap to really drive the reductions forward. Some of you may have seen our roadmap, the sort of the coloured waterfall, as we call it. And if you look on the right-hand side there, we've broken that down into the contribution of emissions reductions that each of those levers will deliver on. Indeed, if you take it from the top, this is why we need and talk to architects, designers, users of our material. We need efficiency in design and construction, demand for our products. We need efficiency in concrete production, savings in cement and binder and clinker production, which is the carbon intensive element of cement. We think that carbon capture is probably our biggest lever, which will commercial level will start to really come on stream and ramp up towards the end of the decade. Important to know that the very first at scale carbon capture cement plant will be live and operational this year, which I think is a really important moment for our sector, that the first plant will be making net zero cement. We've got milestones up to 2030. So by 2030, we want to get to a 20% reduction, 25% in cement, 25% in concrete, and 10 plants that are up and running at scale. We think we'll actually, we think there's some figures that suggest we're confident that we'll deliver 10 plants and more. I'll leave this slide in so that this it's just a bit of a more comprehensive run through of each of the technologies and of the levers and what each of them means, but just for time I won't go through. So not only the global roadmap is the GCCA involved in, but we also work to help to deliver national roadmaps. So we work with a number of the national associations, partner with governments to deliver roadmaps and commitments at a national and or regional level, and our ambition is that the whole globe is covered. We're trying to get to 75% of the globe by the end of the year. Certainly, that is the case in the progress that we're making, because China have made a commitment to deliver a roadmap. We're working with the Chinese industry there. The India roadmap, which is almost complete and ready to be published. Both of those countries, big population. Big and critical for cement and concrete production as well. But then also we need to make sure that the Global South and Africa plays its role as well, because it's the Global South where the majority of cement and concrete production is being produced, but even more so will be as we move through the decades ahead. So it's fundamental that each country does its homework with its national government, and that's what we're moving towards. But in terms of moving forward, we think it's the sort of the key drivers are around policy, the enabling policy frameworks that we need to get tangible change, but also the technology and the innovation drivers, as well as making sure there is demand for lower carbon cement and concrete. In terms of progress, there's no question that our member companies that operate across the world are making progress. Our action and progress report, you can download it there, is jam-packed with case studies across all the different technologies, showing what a handful of the key work that's been done. And I do suggest you download it. We transparently report on that every year. We launch this at COP, which is why there's a picture of Baku, but it will give step by step different levers of some of the examples of the technology, and you'll hear from some of that later in the program. But since 1990, is the glass half full? Potentially 23% emission reduction in CO2. But as we get to the halfway mark of this decade, which we're calling the decade to deliver, we need to accelerate that. And so as well, or to complement the action and progress on the ground that's going on with our member companies, we do think there's greater progress that could be achieved with the policy support to underpin the transition, with driving the innovation and technologies and unlocking the critical demand, the low carbon procurement that we need. And I've done this as a Venn diagram because there's obviously a critical kind of overlap between them. I won't talk to each of the details of this slide, but these are probably 5 of the key kind of policy enablers that we need. Allowing and some countries, some of these already have the policies that they mean that can deliver. And it's our job at the GCCA to make sure that they're taken up in other countries. So, for example, if we look at waste treatment, our kilns can take the societal waste, recover the energy from that, so reduce our fossil fuel use. So it's a win-win for society. We're taking waste that cannot otherwise be recycled, and we're using that for both energy, and it goes within the cement product as well. There are some plants that are operating at nearly 100% of the fuels around the alternative fuels. But there are but we need regulation to be able to allow that and to deliver that. Also, we do with blended lower carbon cements. We're going to need a regulatory base for carbon capture, recognition of carbon removals, but also across public financing as well to support that, and the building of the delivering of licensing, the building of the transport and storage infrastructure. But then also ultimately for carbon pricing, we need to put a price onto carbon to make sure that our member companies can deliver the investment and know that they're going to retrieve that back. And whilst we advocate for carbon pricing, we need to make sure that there is no leakage within that country or within that region that can distort competition, so that investments can be made with certainty and confidence. And I'll get to low carbon procurement at the end, the buying of green cement and concrete, which is absolutely mission critical for us. Carbon capture projects, and why we're confident. We've partnered with LEADIT, again, transparency, to show the different projects which are underway. These are the publicly announced projects, but we've surveyed our members, and there's actually over 100 that are in the pipeline that are not yet necessarily announced. You can see the disparity, though, the global north and the global south, and why we need mechanisms to be able to drive and deliver finance that can encourage the global south also for this critical technology which we see. But we also monitor other technologies, calcined clay, and you'll hear that from Anne later, which actually the global south is using, and calcined clay, which I won't get into, is a way that we can substitute the clinker, which is the carbon intensive element of cement, by using a different key raw material. So absolutely, there's huge reasons to be hopeful, but we need to keep driving innovation. It's the key to unlocking and expediting our transition, and that's why the GCCA runs two major world-class programs. One is with academia, and it's a global research network. It gathers every year. There's 80 different PhDs looking at our roadmap and the levers of our roadmap to help deliver carbon reductions. Davide, who you'll hear from, is actually in Panama now at what we call our Spring Week, which is the annual gathering of the scientists, of the academic partners, of which there are more than 40 different universities, of the industrial partners, of which there are 30, driving that core work around really deep research into delivering and driving real deep decarbonisation. And then on the other side is working with startups. So every year we run a startup challenge, because we know our industry needs new ideas. There's lots of R&D going on, and Davide will talk to some of that. But we want different ideas. We want to partner with startups so that we can test their ideas at a industrial or commercial scale. And we've been running that for 4 years now, with great success. More than 250 startups have centres and applied, and any number of them have been delivered into different consortia, been mentored, their technology has been tested at scale. And we also have actually recently launched an additional Innovandi network for entrepreneurs to have ongoing discourse with our member companies. I won't go through all the universities that we partner with, but just to give a breadth of making sure there's a very good breadth of global coverage. So all the continents are very well covered there. Just in terms of the open challenge, just because of time, I won't get too into that, but you can see here that different consortia with the different challenges over each year are being formed, which is absolutely wonderful, and partnerships between our member companies and the different startup technologies. And this 2025 challenge is up and running, and there's still another 30 days or so for startups to apply, looking at next generation materials, so low carbon admixtures, SCMs, activators, etc., which we're seeking for this live challenge that's open at the moment. So low carbon procurement, I mentioned that it's one of the sort of critical levers, the demand. Low carbon cement and concrete, it's already possible. And these are just a sort of snapshot of examples which you can see in our action and progress report, but it needs policy to implement that. And more so, it needs demand. It needs government, private buyers to demand lower carbon products, so that is actually produced by our members, and they're incentivized to produce and deliver that. But it means we need tools to be able to measure what is lower carbon cement and concrete. So the GCCA provides an environmental product declaration so that cement, concrete, and aggregates and precast products can be measured. And that has third-party verification and really implies deep data collection, which is absolutely the critical building block. But beyond that as well, to underpin that, to underpin sort of the whole procurement which we're trying to build, you need governmental targets, you need baselines for every country to set, but then also a definition system which defines what is lower carbon cement and concrete that provides a level of comparison, so that those procuring can make those informed choices. The IEA very helpfully provided the definitions for low and near zero emissions cement, and the GCCA have used as a baseline to produce cement ratings and also concrete ratings. So we are launching our rating system in April, whereby procurers will be able to ascertain and mark which of the how level of carbon rating are attached to each of the products that they buy. If you want to know more about that, we have a webinar ourselves in March. Just jump on our website and you'll be able to find and hear a little bit more about that. It's a fundamental thing is trying to drive the demand. One of the things that the GCCA does every year is get together all our CEOs and our member companies and leaders, but also this year we're inviting the wider value chain, the wider built environment and policy makers to join us for our conference in June in Mexico City. And just if you have the opportunity to do that for really deep dive and dialogue on how we can really progress this work together, would be very grateful. I'll stop there. I know the slides are going to be shared. Glad to take questions, and thank you.
Thank you for that, Paul. I never actually fail to be impressed with the work of the GCCA. They are an absolute pillar in our industry. We don't have a lot of time for questions. You did go a little bit over time, but I will ask one as my prerogative as moderator today. This is obviously being cement an incredibly hard to abate industry. So in your opinion, is full decarbonisation really achievable?
It's a very good question. And, you know, we used to be impossible to abate, hard to abate. We're complex to abate, no question. You've seen that. You've seen the levers. You know that it's not just around the energy, but it's around the processing emissions. We're possible to abate, definitely, but also we're essential to debate because to abate because of our necessity to society. We think we can do it. We think we can do it, but not alone as a sector and an industry. We need that collaboration from policymakers. We need that collaboration from the entire value chain, and that is our job to collectively build this and deliver this mission together.
Excellent. Thank you, Paul. And on that, we are now ready on time to move to our next speaker. I would invite everyone, though, if you have a question, please put it into the Q&A section, and we will try and answer those either at the end or in text form. And of course, I'll invite our speakers, if they wish to respond to those questions, please do as well during the presentations. Now, if I could please jump to our second speaker tonight. Can I introduce Florian Kleinwachter? In his role, he's the Senior Business Development Manager for CCUS at Holcim. He's focusing on the planning and implementation of CO2 logistics beyond those plant boundaries, including transport, storage, utilisation of the CO2, all while developing logistic solutions and infrastructure projects for their C2B initiatives at Holcim's 3 German cement plant locations. He's previously held leadership roles, including managing directors at Smart and Greenmuckren Concrete, and he was the administration manager at Wasco Coatings in Germany, demonstrating his expertise in project management and sustainable development. It is a pleasure to have you with us today, Florian.
Yeah, thank you very much. Hopefully, I think you can see already the presentation.
Absolutely.
Absolutely. Okay. Yeah. So first of all, thank you very much for this opportunity to speak here today. And I think the speaker before said very clear. So we have a target and we want to achieve this target, and this will play a tremendous role, especially in interfacing between all the different stakeholders and complexity. This is, I think, something which is totally new in the industry, and it's a new kind of industrialization which we will face for in the future. But I think we are very good prepared with the tools we had achieved within the last year. Just some words before We start off our transformation at the Holcim Group in Germany. Some short words to Holcim Germany at all. So we are allocated at about 130 locations. Where we have also include the 3 cement plants, which are allocated here in the north of Germany in Schleswig-Holstein, and 2 other ones in northern Saxonia and northern Westphalia in Höfer and Beckum, around 1,800 employees. And we are already have this topic and product branch for green solutions. So our main focus is especially on cement and binders, aggregates, and follow that the ready mix concrete side, and as well on the product and solutions. And especially there will be mainly in the next upcoming years an additional business segment which is called CO2, because CO2 is an emission, but if we can produce it as a raw material and be sure that we can bind this CO2, this will have a real big impact as well, because the sea atom is needed for our modern world. It takes in every supply you have at the moment on your table. Look around, there's in every part of these products, the sea atom is included, and due to decarbonization in the industry, especially from the fossil fuels, we will have a huge demand for the sea atom, and this is why there will be an upcoming business segment as well. So just to remind, and we know that we as a cement industry are reliable also for these emissions, with between, on the statistics you're looking between 7 to 9%. It's a huge anchor you have, but we will need more cement in the future for that modern world. Just remind on the infrastructure for the energy transition we want to build, for all the windmills, for all the foundations we need, for the energy transition lines, for new buildings, construction, especially in the north of Europe. It's a big topic. Also for the infrastructure, may you have reached the news that yesterday the German government has announced 950 billions of euro, and where 500 billions will become especially for infrastructure and climate actions. So this was, I think, yesterday the right step in the right direction. But, and this is really our aim and also our goal, is that we have to become more sustainable, especially in building materials. Especially in the past, we have used concrete and we have used cement, but in the future, I think we just storing concrete in buildings, because we have to take care that those products are coming back to our site. So may I have a problem right now? Can you hear me?
Yes, we can hear you. Florian seems to be having some small technical difficulties there. Just give him a second to... Florian, are you back? Unfortunately, we cannot always guarantee that we don't have technical difficulties. Florian, we can see you and we can see your slides.
Maybe move to the next presentation and come back to Florian.
Florian is still on camera though, if you can hear us. He has jumped off. Oh, apologies, we will come back to Florian's presentation and questions you will have. I'm going to be putting you on the spot now, Anne, and I'll quickly run through. Anne Decker-Carrara is the Director for the Centre of Worldwide Sustainable Construction at the EPFL University in Switzerland. She has 28 years experience in the cement industry and is also the facilitator of the Cement and Concrete Breakthrough within the Breakthrough Agenda Initiative. We are absolutely honoured to have you with us here today, Anne, and you'll be speaking about the LC3 project, I believe.
Yes, thank you. Thank you so much. And thank you for the invitation. I will walk you through a new cement, the LC3, but let's begin. Do you see well on my screen, correct?
Absolutely, yes.
Okay, thank you. So first of all, before talking about LC3, I just quickly talk about the university, who we are. We are EPFL, Polytechnic Federal University of Switzerland in Lausanne. Within the university, we have 3 faculties: architecture, civil engineering, and environmental engineering. So that's why, and sorry for my coughing sometimes, still recovering, but so we are covering in the university all the elements of the built environment, from civil engineering, material engineering, architecture. So that's why the ambition of the university is really to tackle sustainable construction as a whole and as a big value chain. So that's where somehow in the material science and engineering lab, LC3 was invented. It was in 2013. The LC3 cement went out of the lab in the industry in 2018, and here we now are in 2025 already. So I will go through some of the elements. So just to come back, I know Paul and the others already put the stage, but why is it urgent to decarbonize the built environment, especially the building materials? Is because embodied carbon emissions are upfront, which means that those are the emissions that happens in the beginning of any project. Before we saw that operational emissions were higher than embodied emissions, but we expect for the future, since the whole built environment will happen in Global South, we think that the embodied emission will have a higher percentage compared to the overall built environment emissions. And that's why it's important, and that's why it's important to tackle it now, and that we have maybe 1 decade to really change quickly the path. I think that was also already mentioned, that 3/4 of the infrastructure that will exist in 2050 has yet to be built, and that we expect 1 New York City every year until 2060. And what we know is that this will not happen in the Global North, but it will happen in the Global South, and especially we think it will happen even more in Africa. That's where the whole development will happen, the whole infrastructure, the whole building, residential, and all this will happen even more in Africa. So this was the pattern of the cement consumption. We can say, okay, it's somehow it will be the pattern of the building materials, Global North, Global South. So you see on the bottom, the Global North is very small. China has increased, has developed rapidly, and will go down, but that's what we expect, that Africa will go up, Southeast Asia and India also. So I will show you here 2 different roadmaps. Sorry, one from IEA, where they also emphasize part of the lever to decarbonize is the reduction of clinker to cement ratio. So the reduction of the clinker into the cement, as Paul said, it's the element that has the highest CO2 intensive, is the highest CO2 intensive. And I will show you also the GCCA roadmap, where the line savings in cement and binders, that's where the clinker factor will have to decrease and being replaced by other materials. So what does that? Yes, this LC3 first. What is LC3? In fact, it's very easy. On the left side is the ordinary Portland cement, which is the oldest cement recipe that we have, where 95% was clinker. And the new LC3 replaces 40% of this clinker by calcined clay and limestone. What's happening is that calcined clay has no chemical CO2 inside. So we only have CO2 from the fuel combustion. We only need to calcine the clay until 850 degrees C versus 1450 C for the limestone. And we add the 15% of limestones, which is zero CO2 because we don't have to heat it up. So we made this formula which reduced the overall emissions by 40%, 40, which is quite massive. So let's go back, one step back, and say, okay, what would be the supplementary cementitious material that could replace clinker? So we have different elements. We have limestone. Limestone is in the recipe of LC3, but limestone alone will not provide additional strength, which means that you may add a limestone to your recipe of cement, but to a certain percentage. Over that, your strength will decrease. Second option would be the fly ash. Fly ash is generated from coal-fired furnaces. And we know that, okay, coal-fired power plants are set to decrease in the future. So the availability and the quantity of this waste will decrease and will disappear one day. Then we had also slag. Slag was a very good, is still a very good cementitious material. It's from a waste from the blast furnace. The issue is that the volume on Earth is already used. We expect the overall volume of slag to reduce because the steel industry will go from blast furnace to electric arc furnaces. So that will reduce the slag. We also have natural puzzolana, which some are reactive, some are not reactive, but it varies widely from region to regions. So there we don't have the availability of this resource everywhere in the world. It depends. And then we have calcined clay. We looked at calcined clay as a resource that is available worldwide in huge quantities. Just to show the availability of SCM worldwide in terms of quantities, you see the slag is used nearly at 95% worldwide, and there is a certain quantity available. Fly ash is available, and we also use much, but there is a lot of different qualities in fly ash. Then you have Portland cement, that's a huge volume, and we have the two elements, limestone and calcined clay, that are extremely available worldwide. So availability is not the issue. Here you can see all the regions in yellow, pink, and light greens are where suitable clays are available. Suitable clays, we mean by that kaolinite content clay. For example, it is also a waste. This is a deposit in India where it's a stockpile of waste, where we used this as a perfect clay for our product. And it was a waste. It was a waste from the China manufacturing, where they dig clay, and they need a very high purity clay, which means that often they dig 5 out of 5 tons of clay, they only get 1 very pure clay for the product, and the 4 tons are discarded and stockpiled there, which means that those less good quality is perfect for the LC3. Let's come back to the recipe. So as I said, 50% clinker, 30% calcined clay that has to be calcined at 850 degrees C, which means, yes, we need a calciner. I will come back to that. 15% limestone, 5% gypsum. With this, we have 50%, 45%, let's say, less clinker, 40% less CO2. We have the similar strength as the ordinary Portland cement, and we even have better chloride resistant and alkali silica resistant. So it's a product with much lower CO2 and the same properties and even better than the original recipe. This was to compare the strengths development of OPC and LC3 with 50% clinker. We really have nearly no differences. So which means that we can use LC3 very quickly and change any cement by LC3 and use it like any other cement. So that was really the positive side. 2014 versus 2024. 2014, when the product was still in the lab, they did 2 houses with LC3 in India on the left side. And since then, on the right side, you may see that it has improved a lot. Argos in Colombia has taken it up very quickly, is building bridges, highways, commercial center. In Switzerland, we have one of tower on the left side, the Tilia Tower, 27th floor with LC3, and the Rolex campus just announced to build the whole campus also with LC3, which we are very proud of. Where are we? So the projects are popping up a bit very quickly worldwide. And as Paul said, it's coming on the global south. Because it's implemented very quickly, it has an investment cost because of the calciner, or you can either convert your clinker kiln in a calciner kiln, or or buying a new kiln, and that's the investment. But it's not a huge investment. The return on investment there is maximum 5 years. Additionally, producing LC3 costs on average 25% less than OPC. So that's why we see a lot of projects emerging. And we even did the calculation, which means that until 2025, 13 million tons of calcined clay capacity will be in place, which means that depends the calculation we do. This means between 8 million tons of CO2 reduced per year or 15. So it's between 8 and 15 million tons of CO2 per year, which is massive. And that's where we put it's on average 25% of the country, the Switzerland as a country, its emissions. Let me come back if I didn't forget. Sorry. Yes, you have the CapEx, and that may be somehow what the cement industry may be more cautious to enter. Is there is an upfront CapEx requirement in order to begin to produce this calcined clay and produce this new cement. But the result is quite significant. 40% is huge. what we are missing maybe is, I know a lot of big cement producers like Holcim, CEMEX, Argos, Heidelberg are entering. What we would love is that every cement producer begin to investigate in this and make the step in investing in a calciner and beginning to produce LC3 and going away from OPC and build what we need to build. Right. Hope it's clear. Thank you.
Excellent. Thank you, Anne. Just before I ask you a question, I've just had a small update. Florian has experienced some catastrophic technical difficulties and has another commitment that he needs to get to. So unfortunately, we won't be able to go back, but we will be able to present a copy of his slides when we do publish them after this event. So with that small announcement, Anne, I have a question for you, if I could, please.
Yes.
Why do you think that the LC3 solution isn't actually being implemented faster? Is it a finance? Is it the capital costs? Is it awareness? Combination of things. What do you think?
It's a combination of everything. It's a capex, yes. Even if it's much lower in terms of capex than any new cement plants, it's capex. And maybe also because for the moment, cement industry are not really obliged to reduce, even if a majority committed to reduce the CO2 emissions. We have to know that the cement industry in the world is very fragmented. So even if the leaders are moving, we still need all the others to move also and to take the same path. And maybe for them, okay, it's a huge capex. Maybe for a family-owned cement plant, it can be a huge capex. Even as I said, the return on investment is very, very quick. In terms of perception, it's a new material. It's not a new material, but as any new product, they may fear, is the strength okay? Is the durability there? I don't know this product. I want to see first. So we have this new product fearness, I would say. In terms of regulation, LC3 is in the regulation, which means that they are under the EN 197.5 under CEM2C, and they are under the ASTM. So they are well under the two largest cement standards. So you can produce without any problem tomorrow the cement. Then you have to see if it's in the building codes and if the civil engineer understand the cement, if they want to go through with, if they want to try. What I would push and recommend is that really, that's what Switzerland did, is that there is no incentives, but one said, okay, why not? I will try this new cement and I will try it in my building that I'm building now. Is really, and the reaction was great because they looked and they worked with this concrete, they look at the finishing, they look at how it was, and they were really amazed. So it's really the first step, and more demonstration project we will have, the more and more the confidence will increase. But it's like any new product, it has to eliminate all the fearness and all the...
Excellent. I'd have to agree that we see a very common element when it comes to new technologies or any change that comes to industry is overcoming those fears, building the trust and confidence to not just be first, but to even follow what's happening. Just on that, there is that question that's been asked in the chat, and it does relate to what you've just mentioned. It says, could you talk to any regulatory issues here? I know you just mentioned standards and codes. And the question says, I understand countries like India struggle here for a full rollout. Have you had any experience on that space?
The thing is that India still has a lot of coal plants, which means that the availability, like I explained, the availability of fly ash, which is very cheap and they don't have to do any investment, is there. So they would, even if the reduction of clinker is lower than the LC3, they say, why should I invest in a new technology to go to 50% when I have a product that is available everywhere in my country? Even if I can only reduce to 15% replacement, but it's there. I just have to buy. I have to buy, or for X price, which I don't know. But you see, this is. But on the long term, we know that the fly ash will disappear. But in the short term, they say, why should I go to LC3 when I have fly ash here available in my country massively? You see?
Excellent.
Should we put it in a regulation? Yes. Or should we, as Paul mentioned, coming with those new cement definition with A, B, C, D, E, F, G. And maybe if I'm producing a cement which is B, and my neighbor is producing a cement which is D, and there's a beautiful government project for a hospital, maybe the government will come to me and saying, oh, but you have a cement B, which is better, I will come to you. So that's, at one point, it's somehow a decision that companies will have to come up and saying, yes, I want to invest now for the next 10 years at least, because that's what will happen is the next decade.
Excellent. Well, thank you so much for that, Anne. I can't see any more questions in the chat at the moment, but if you do have some more questions there, hopefully we'll have some time at the end to circle back. Our next speaker tonight, if I could introduce please, is Davide Zampini. Now, Davide holds a PhD in civil engineering from Northwestern University in the US, and he brings over 30 years of experience in the construction, materials and cement industry. He currently heads up the research and development capabilities at CEMEX, where their research covers fields ranging from the design of novel construction materials through to novel digitized construction systems. Everyone, David is going to be speaking today about the Solar Clinker project, so please welcome Davide.
Can you guys see the slides and can you guys hear me?
It's still in edit mode rather than presenting mode, but we can see them.
But yeah, I'm going to put it in presenting mode in a sec. So let's see, here we go. So it's in presentation mode. Correct?
Excellent.
Okay,
absolutely.
Okay, so yeah, so thank you very much for this opportunity. As you guys have seen, the calcined clays are an important, let's say, lever that the industry is pulling to reduce clinker factor, and then fortunately we could not hear Florian's talk, but I think as pointed out by Paul, carbon capture, storage and utilization is also very, carbon capture, utilization, storage is an important, let's say technology that the industry is relying on to decarbonize significantly its CO2 emissions. But today I would like to talk a little bit about, let's say, an alternative innovation that could actually make a big difference in terms of decarbonizing the industry, and it's about solar clinker. But before that, of course, a couple words on CEMEX. For those of you who don't know what CEMEX may mean, there's a little cocktail party, let's say, conversation you could start off by saying, that, hey guys, do you guys know what CEMEX stands for? And CEMEX stands for Cementos Mexicanos. So we're some Mexican-based global, let's say, sustainable construction materials and solutions company. On this slide, you can see the facts and figures. I mean, we're almost 120 years old, and we're 44,000 employees, or a little bit more. And you can see that our core businesses is, ready-mix cement and aggregates. So I don't want to dwell too much now on the figures, but you'll have the slides and you can. But we're a global player. So solar clinker. I mean, when we talk about solar clinker, I mean we're effectively talking about how do we harness solar radiation and use that to drive the whole entire clinker production process. So the first part of my presentation will focus on the technology, and when we talk about solar radiation or solar-driven, let's say, manufacturing processes, we're specifically talking about concentrated solar thermal power. How to harness the energy that's in the sun rays and literally, and then and take it to drive a process through heat. And one way, I hope that I'm going to be able to convince you that actually, concentrated solar thermal power is actually child's play. I don't know how many of you remember, but I remember that, when I was very young, they handed me over a magnifying glass, and I started to explore and play with the magnifying glass, and I figured out that I could actually, take the rays of light and concentrate it to a spot and actually light up a match. And here you can see a bunch of children actually, being very creative in creating a smiley face or a mask that is a smiley face. So again, I think, and I hope I can convince you it's child's play. But what is concentrated solar thermal power in essence? In very high level, simple terms. Basically, you have the sun emitting rays, and that the rays of sunlight are basically focused and concentrated, through heliostats, which basically are mirrors, mirrors designed in a very specific way so that they actually are able to take the sun rays and actually focus them, concentrate them into a receiver in this particular case. And that, that heat actually is then used to drive a thermal process, and that thermal process then, either moves a turbine or generator and then produces electricity. So that's very, very simple terms. And in fact, if you go back to March 2007, there was a very first already solar power plant, commercial solar power plant, solar radiation power plant, the PS10 Planta Solar 10, that was in Andalusia in Spain. And, it really marked the beginning of the large-scale development of this sector for harnessing solar energy. Of course, what is the issue with this? So you're saying, okay, well, the technology is existing. We've been able to drive, let's say processes that require temperature. But there, the challenge has been, to create the technology, to develop the technology, to take, that heat and raise it to a certain temperature, right? So what you see on the table here is, it's a documentation of how, let's say, different concentrated solar thermal power, let's say, initiatives have been put forth in the years to drive the temperature of, let's say, either a gas, a liquid, or solid to a certain temperature. But what caught our attention, at least from the CEMEX, is that there's a company, a startup or a spinoff from the ETH in Switzerland that's called Synhelion, and we were researching this information. We've already participated. There was an EU project, that's called Solpart, that actually was focusing on how to, harness solar radiation to drive some clinker manufacturing, if you like, and they reached 1,000 degrees. But the Synhelion guys, came up with a technology that actually reached 1,600 degrees. And 1,600 degrees, you will see, I will be more specific later, becomes very, very important and relevant if you're talking about clinker manufacturing. So a few words to the guys from Synhelion, because I think they this is, we are actually partnering with the Synhelion guys, and they actually are born as a company that's, who has its objective to actually produce solar fuels by having a process by solar fuels using solar radiation to basically combine CO2 and water, and you can see that they have a very clear roadmap towards net zero, and they're working with important, let's say, airlines worldwide to produce actually sustainable aviation fuel, SAF. So this is the team. So I think that if you once you have the slide, you can actually go and check out these guys. But they're very bright people, and we were very excited to actually have this opportunity to team up with them. And so we decided to partner with them in 2020 to explore what it means to use solar radiation to drive the entire clinker manufacturing process. Now, what is under the technology know-how of Synhelion. They have 4 proprietary innovations. Now, one is the solar receiver, which is key. It's the unique and only solar receiver today that can actually take temperatures of gases up to 1,600 degrees. And 1,600 degrees is very important because that's exactly the temperatures that you need to drive the clinkering process in the furnace, in the kilns of where we manufacture clinker. But they also have, also under, let's say, their knowledge is, thermochemical processes then to take, the CO2 and water and to produce the fuels, and they have, proprietary technology there. But also, I think an essential part of this is how to store that energy. And so the thermal storage, energy storage bit is also something that they have considerable knowledge on. And they also have and they own also a company that actually produces heliostats. So, and all the, let's say, technology that's required to control the heliostats, the mirrors that need to focus the sunbeams, the sun rays. Now, what is really interesting and ironic in some ways is that, what the Synhelion guys are doing and what they're heating up in their receiver up to 1,600 degrees is CO2 and water vapor, not the greenhouse gases. I mean, because the greenhouse gases, they're heating up, our atmosphere is because, they're the easiest and the best to let's say, to absorb the heat. And so you can see that, I don't want to go into all the technical details, but basically, if you look at the spectrum there of absorptivity, you can see that CO2 and water vapor are the ones that are absorbing the heat. So they're perfect and for, let's say, being the heat transfer fluid. So basically you can, incorporate mixtures of CO2 and water vapor in the solar receiver, and the way the proprietary solar receiver from Synhelion is able to, reach very high temperatures, 1,000, as I mentioned, 1,500 with great efficiency, over 80%, even at a moderate solar concentration. Okay. So, and, in March 2020, and coincidentally, when we actually start to knock on their doors, they were able to actually create a first prototype that could, 250 kilowatt receiver prototype, tested it in Germany, and showed that, it was really it's really possible to reach 1,500 degrees C. So now the question is, okay, we saw this and we said, okay, well, how can we apply this to the manufacturing of clinker? So I think, it's important to keep, that you keep in mind that, and maybe to remind everybody that the CO2 emissions come from the fuel, and they come from the chemical process of decarbonating, let's say, the limestone, which is the source of the calcium that we need to manufacture clinker. So these two points are very critical in terms of the CO2 emission. And so, when we went to talk to the guys from Synhelion, they were very much focused on producing fuels. And we said, hey, guys, could you imagine, using, your technology to drive the whole clinker manufacturing process? So this is obviously a digitized version, but literally what we did is we sat down and we sketched out this diagram. Says, okay, you have this receiver, and basically you have this, heat transfer fluid that's composed of CO2 and water vapor in different proportions, and that would drive the whole clinkering process. And then what is really interesting is that afterwards, you would, let's say, the heat that's coming out, that is basically composed of CO2 and water vapor, is used also to heat the limestone. And as we heat the limestone, obviously the CO2 that's being emitted is further concentrating the CO2 in the gases. Let's say the HTF, the heat transfer fluid, and that heat transfer fluid actually is just composed of CO2 and water vapor, and it's actually very easy to separate the water vapor from the CO2 by condensing the water, and then you can actually take that CO2 and use it, store it, or do something with it, and part of it you can actually circulate back in as the fuel, if you like, as the heat transfer fluid. And of course, then what you would do is you could actually harness the heat from the sun, drive the process, and also actually, use the thermal energy storage unit to store the energy, and then, take that energy when you don't have the sunlight, at night, for example, and then basically, drive the process, despite the fact that we don't have any sunlight during that moment. And So what I wanted to point out here is that, before we embarked and got in deeper into the subject matter, I mean, obviously we conducted a feasibility study with the folks from Synhelion, and, there were many critical aspects that we addressed, like, okay, dimensioning the solar field, the thermochemistry of the clinker, which we'll come back on in a moment, because, it's not, it's not given that, if we're burning with certain types of fuels right now, call it alternative fuels, call it natural gas, or whatever that may be, fossil fuels and whatnot, the characteristics of the fuel that we burn obviously can affect the clinker chemistry. So we have to check that, how to transport that heat, and many other aspects that we had to really take care of. So the feasibility study actually was highly encouraging, because in the end, the conclusion was that, hey, look, this is something really, that can happen and that we can really pursue, and from a technical point of view and from an economical point of view. So again, here, it was, in the end, we saw some very exciting opportunities, and the outlook was very positive, when we started to look at this, so this is kind of to recap a little bit. So you have basically the sun coming in, a bunch of mirrors, let's say, focusing the sun rays into a solar receiver that is proprietary, unique, that can take the gases up to 1,500 degrees, produce the clinker, take part of that, CO2, produce the clinker, obviously, because of the temperatures, heat up the limestone, concentrate further CO2 into the gases, be able to, and then, separate through a very easy process of condensation, take part of the CO2, put it back into the system, and then part of the CO2, in this particular case, we have a use for the CO2 because Synhelion happens to be interested in the CO2 for producing the sustainable aviation fuel. But you can see the numbers there now. So we can really replace up to 90% of the fuel costs, reduce the fuel cost by 90%. We can separate at a cost that's 60% less than, let's say, we would do carbon capture. And I think, we could capture 100% of the CO2. So I think, the question then is, okay, so we have all the ideas, all the feasibility study shows that, we could do it. So we had to find a lab and a place to actually test the concept. So we actually went to IMDEA. It's let's say, a concentrated solar thermal testing facility, and you can see the characteristics of this facility. And IMDEA is actually a research institute that actually is focusing on energy-related technologies. So they luckily Synhelion guys had already let's say agreement to run some previous tests, and we had the opportunity to really test and evaluate a small pilot. And one of the key focuses on the pilot was, as I was saying before, is to see, what would be the impact of the different mixtures of CO2 and water vapor on the clinkering process and the calcination process. Would it be the same, or would we completely alter the way we would actually achieve clinker, or are we going to change completely the chemistry, and what would be the heating curves? When would the phases form? So many questions, right? And without going to the details, basically, we tested in the lab, and we said, okay, we simulated, mixtures of H2O and CO2 vapor, and we take that, up to 1,500 degrees. What would be, how would it affect the calcination process? Well, because the CO2 is in the gas, we have a vapor phase effect. So we do increase slightly the temperature of calcination, but that's not a big deal. We look at the clinker chemistry, and basically, we're very satisfied, and we have a perfect match with what we would normally produce in a regular cement plant that's burning other types of fuels. So then we ran a small pilot at IMDEA. So the first pilot was a batch process. Basically, we took the raw materials, put it in a furnace, and basically blasted it, at 1,500 degrees, and using solar radiation, we produced the first solar clinker back in Q4 in 2022. And then, a couple months later, we said, okay, let's kind of, let's do this and demonstrate that we can, produce the solar clinker in a continuous way. So we actually had a continuous moving bed, vertical continuous moving bed set up. So it also speaks to the fact that, maybe the production of clinker can be revisited. Maybe you don't have to, use the conventional kiln that we're using today, but maybe a different type of way of heating up materials. So you can see in this second pilot, we were able to produce also in a continuous way the clinker and achieve, the clinker chemistry as shown here. So you can see the certain temperature profile that we documented. So the clinkering zone, there's a calcination zone, and we can see that in the end, we can even produce the clinker, a solar clinker, in a continuous fashion, and complying with the clinker chemistry that we need. So this is all very promising, and it's showing that we're step by step de-risking the technology. So what is the roadmap? So you can see, there's in 2022 and 2023, I think, there was 2022 is proof of concept. We took it, and demonstrated that we can produce continuously. The guys from Synhelion, are, already scaling up. And this is also very promising for us, already scaling up the technology to produce, let's say, sustainable aviation fuel. And they're demonstrating that daily since starting from 2024. So I think, the roadmap is quite promising, so we're looking to see now if, let's say 2026, 2027, to run a larger, let's say semi-industrial scale, either calcination or clinkering trial. And then, and hopefully we will, by, let's say 2032 or mid 2020, so roughly around that time, even be able to scale up to a much larger, let's say, setup. So I think that the technology is able to achieve the required temperatures in continuous operation. Talking to Synhelion guys, we can offering a low cost of any renewable energy source. It's seamless way to capture and concentrate the CO2 from the calcination process. But of course, there's the big challenge that it requires a sizable footprint. You can see there. You need about a huge field, almost a kilometer square, let's say, field to produce, let's say, a certain amount of, let's say, energy to produce the clinker bus. So I'm gonna end by with this video showing you that it indeed concentrated solar thermal power is child's play. You can see in this video, we literally is a video showing how we're actually in the process. When we start up the whole process, we are using the mirrors, and you can see the rays of light as you would do with a magnifying glass as a child. We're actually taking that heat and concentrated into the receiver, and then starting the heat up process now. So anyways, and then maybe I just want to, because Paul did mention, the GCCA. I mean, at CEMEX, we are working on innovation in different fronts. So we're, actively supporting startups, either through the GCCA Open Challenge or through our CEMEX Ventures group. We have own R&D facility, R&D, let's say, capabilities as well, and resources, but also, collaborating with other industries through the GCCA. And in the Vande Research, let's say, network, we have a number of, let's say, topics that we're addressing, as you can see shown in this slide. So thank you very much for your time. I appreciate the opportunity, and I hope you found it interesting.
Excellent. Thank you, Davide. I do have one question here for you. Would you be able to highlight for us what are the key elements that will accelerate the development of this technology and bring it up to full scale?
Yeah, I think, as I highlighted, I think what has really been key and what we've been trying to do now is that we have been, stepwise de-risking and showing stepwise, how, really this, everything that's related to this technology can really lead to a serious production of the clinker manufacturing. I think the scale up is going to require, drive from the industry, important funding schemes, that see to it that that we can really bring this to the next level. So I think funding, the de-risking work that we're doing, and really creating the credibility that there is a very solid technology behind that can help decarbonize the industry.
Excellent, thank you. I don't see any more questions specifically for you. We do have some time though to ask some questions. There's a question from earlier. If everyone, I'll just draw your attention in the Q&A section, the questions have been answered both by Paul and Anne in the comments, but there is a question I don't think we've had an answer to yet, and it's from Sajade. Which is more cost efficient for decarbonisation, hydrogen as a fuel or using carbon capture technology after the fact? Now, I don't know that there's an exact answer for this yet, but I'm happy for any of our panelists to actually offer a suggestion. Paul, could I throw
Well,
to you, because I believe the question was targeted you in the first place. Is the technology, for example, mature enough to even have a guess at this stage, or is it still too immature?
I can take a stab at it if you like, Alan. I mean,
please.
Yeah, I mean, of course, I think both, carbon capture and hydrogen are two technologies which the industry are evaluating and pursuing. Obviously, carbon capture has its clear roadmap and path. I mean, I think the industry, is doing a good job of exploring different types of carbon capture technologies, and I think I think the economics still are really, are complex in the sense that it's still quite expensive to do carbon capture. But obviously, we need to be in testing as an industry what the carbon capture technologies are, and understand what are the options that the industry has. And of course, there's no single technology that's going to be the proper technology for carbon capture in each of the plants. So that's why we need to explore and understand which are the ones that will work and the ones that will give economic viability. But that's a process, I think, where the industry is still working. On the hydrogen bit, I think is, if you're talking about, let's say, what type of hydrogen, if it's green hydrogen and whatnot. But I think what the industry is doing right now is that we are injecting small amounts of hydrogen into the kilns, and the small amounts of hydrogen that we are able to inject into the kilns are making the burning of alternative fuels more efficient, and we can burn more alternative fuels, and thereby we're also reducing our CO2 emissions. And I think going to the pure hydrogen technology, I think that's still something that, is being evaluated and pursued. So I don't think that there is a clear answer today. I think what is clear is that the industry, and I think, I hope that the talks today do demonstrate that is very active and moving in many directions, and, very actively to accelerate technologies that can decarbonize our industry. So I think, I don't know if Paul, if I answered properly, but I think that there's still work to be done, and I think the techno-economics are still to be understood.
Excellent. And
I don't have a better answer than that, for sure.
If I may just, we may
Please.
not forget that decarbonizing the fuel of the industry will only solve 40% of the emissions. Knowing that 40% comes from the fuel, 60% come from the product itself. So we need to have a overall view and looking at the solution for both of those emissions, and tackling only the fuel will only solve 40%. So this is very important.
Excellent. We will be able to pass on the question. There's a question in the chat there, whether or not we'll be able to get the question to Florian, and yes, we will be able to pass that on to him after the meeting. But thank you for that, and it's an excellent point. One of the big challenges we have is obviously how diverse the challenges are, not just for cement, but for the other heavy industries. And that's why Mission Innovation has 7 different technology pathways that we're monitoring, which also include electrification and circular economy and alternative materials, which obviously some of these projects come under as well. If there's no other questions, I'd just like to thank all of our speakers for those absolutely gripping presentations. I can't resist not making the joke for Davide that I think that solar thermal power has a bright future. But if I could please pass to Urban, who's going to give a quick wrap-up of our presentations today.
Yeah, thanks a lot, Alan. Thanks a lot for all these really wonderful and really inspiring presentations. Paul, particularly thanks for your starting with pointing out again the magical aspect of cement. That brought me to kind of my childhood when I first saw this dough-like structure, and the next day you can walk on it. So it's truly something magical. And if you look around, you forget this. But it is so much around in our daily life, cement and concrete, and it really is a is fundamental to our wealth, and it certainly safeguards a wealthy and sustainable future. And there are obviously enormous growth expectations globally and in very concrete terms for the global south. And I'm really happy that we have seen and to some extent proved that solutions for net zero cement and concrete are readily available soon. And looking at the announced CCUS and clay calcination kiln projects, I think this is really promising. Obviously, there are new cement recipes out there already, and they have left the lab. And David, thanks for your presentation as well. Solar clinker, I think that is something that would have sounded only a few years ago like science fiction, and now it has reached really promising technology readiness levels. So overall, I think the cement industry is prone to serve as a very good example for a double dividend. So economic benefits and climate protection that do not hinder each other, but are really going hand in hand with each other. And overall, I think the transformation of the cement industry is obviously not only about reducing greenhouse gas emissions. It's about the fundamental modernization of the industry, and it's about future value chains and new ways of collaboration. And unfortunately, we have missed Florian's presentation, but I think we will have seen how new products and new markets and new value chains and new value networks are coming up in the context of cement and concrete. And obviously, reasonable return on investment times for innovative solutions seem to be within reach. This is really promising. Obviously, as well, policy and financing are very important boundary conditions that need to interplay well with innovation. And trust is again at the center of this whole development. But I see that this trust is building up, and when you start speaking about complex to abate and not so much about hard to abate anymore, maybe at the end of this decade where we need to really prove that things are changing, we speak about ready to abate, and I think this is where we should end up. And this should be the state of play where we are and where we really need to deliver. Thank you very much. Thanks to all the speakers. Thanks for your questions. Please do not hesitate to reach out to us even after this webinar. I think Thomas has posted a feedback request in the chat. Please, come back to us. We will continue with this series of webinars with other topics in the energy intensive industry and in interesting technology pathways. Looking forward to meet you again in one of the future webinars, and I hand back to Alan for probably your closing remarks.
Very short closing remarks. Just again, a thank you to everyone who's helped organise, everyone who's presented today. And please do have a look at the links that Thomas has put into the chats for our website, for our LinkedIn page. And please feel free to send us suggestions. We're here to actually help industry decarbonise and accelerate that decarbonisation as fast as possible, to promote and share as much knowledge and information as we can on the technologies that will help our industries to decarbonise, which means that we need to listen as much as we need to talk. So thank you all for attending, and until we next meet, thank you very much, and good day and good night.